Hello students, welcome to Vidya Myriad. Today I am starting with Triangles Chapter 7 for class 9. Let's begin with exercise 7.1. Question number 1. In the quadrilateral ACBD, AC is equal to AD and AB bisects angle A. Show that the triangles are congruent, and what can you say about BC and BD? Now first of all, we will start the question by writing the given, whatever is given in the question. We are told that ABCD is a quadrilateral and AC is equal to AD. We have marked it with the line also, and we are also told that AB bisects angle A, which means your angle 1 will be equal to angle 2, or we can also say it that angle CAB is equal to angle DAB, as it is already given in the question. Now what we have to do is we need to prove whether both the triangles are congruent or not. So let's begin our question. In triangle ABC and triangle ABD, let us see what all is there with us. AC is equal to AD, it is already given. Angle 1 is equal to angle 2, that is also given to us. And the third thing which we need is AB, which is common in both of the triangles, and we can write it common. So by SAS side, there is one side, then there is one angle, and again there is one side. By SAS, triangles are congruent. Now the second part is they are asking, what can you say about BC and BD? Now if you say in both the triangles BC and BD, they are the parts of the congruent triangles. So we can simply write it as BC is equal to BD by CPCT. Question number 2. ABCD is a quadrilateral in which AD is equal to BC. We will write it in a given form, and angle also is given. Angle DAB is equal to angle CBA. That will also write in the given in the solution. First thing is we need to prove triangle ABD congruent to triangle BAC. So let's begin with it. In the triangle ABD and triangle BAC, I have marked it with the red line so that we can focus over there. We can simply write AD is equal to BC as it is given to us. Even angle DAB is equal to angle CBA, which is also given to us. And the third thing we need to find out, if you see AB is common in both the triangles, we will write it out. AB is equal to AB, which is common, and hence the triangles are congruent by SAS property. Number 2, they are saying BD is equal to AC. Now if you see BD and AC, both are the parts of the same triangle. So with the help of CPCT, we can write it BD is equal to AC, and reason given is by CPCT. Third part, we need to prove angle ABD is equal to angle BAC. Now see, these angles are also the parts of the same congruent triangles. So we can simply write angle ABD is equal to angle BAC by CPCT. Question number 3. AD and BC are equal perpendiculars to a line segment AB, as in the figure. Show that CD bisects AB. What do you mean by CD bisects AB? That means we can prove AO is equal to OB. Now first of all, I will write down what is given. Now given is AD and BC are perpendiculars. Now when they are perpendiculars, it means angle formed will be 90 degrees. So OBC and OAD both are 90 degrees. Now we need to prove both the triangles congruent. Now in triangle BOC and triangle AOD, let us see what all we have. We have angle 90 degrees, both are equal, it is given to us. Number 2, BC is equal to AD, that is also given to us. And number 3, we need to find out, if you see, I have mentioned angle 1 is equal to angle 2, which is vertically opposite angles, because there is no other thing available to us. So we can mention it as vertically opposite angles. So by AAS property, triangles are congruent. There are two angles and one side. So we will write AAS. Okay. So by when the triangles are congruent, with the help of CPCT, because OB and OA are their parts, we can mention OB is equal to OA by CPCT, and we can also say that O is the midpoint of AB, Thus CD bisects AB. Bisects means dividing the line into equal halves. Number 4. L and M are two parallel lines intersected by another pair of parallel lines P and Q. As in the figure, we need to prove that triangles formed ABC and CDA both are congruent. Now we know the parallel lines properties, that with the help of transversal we can find out the angles equal. If you see, I have mentioned, now taking the lines P and Q as parallel and AC as transversal, it means that angle 1 is equal to angle 2 because of the alternate interior angles. And if I take L and M parallel and AC again as transversal, in that case angle 3 is equal to angle 4, again alternate interior angles. Now if we take both the triangles ABC and triangle CDA, we will mention these angles. Angle 1 is equal to angle 2 according to equation number 1. Your CA is equal to AC, that is a common line, diagonal line in between, so I can write it as common. And number 3rd will be angle 3 is equal to angle 4, that is as per equation 2. So in all the 3 ways, our triangles are congruent by the property ASA. Next question. Line L is the bisector of an angle A and angle B. Bisector means it is divided into equal halves. So it means angle 1 is equal to angle 2. You are also told that BP and BQ are perpendiculars from B to the arms of angle A. So what happens is, you need to prove that triangles are congruent, and number 2, you need to say BP is equal to BQ or B is equidistant from the arms of angle A. Now let us see what is given. We have mentioned angle 1 is equal to angle 2, it is given to us, as well as we can also write that angle APB and angle AQB, they are 90 degrees, which is also given to us. So let us take both the triangles and find out what are the 3 things which can be proved to make the congruence. Angle APB is equal to angle AQB, which is 90 degree, as they are perpendicular and it is given to us. AB is equal to BA, it's a common line in between both the triangles. And number 3rd, angle PAB is equal to angle QAB, or I can also write it that angle 1 is equal to angle 2 because they are the bisectors. So by AAS property, the triangles are congruent. Now we are told that BP should be equal to BQ. Now both are the parts of the congruent triangles. So we can simply say that BP is equal to BQ by CPCT, or B is equidistant from the arms of angle A. Question number 6. In the figure, AC is equal to AE, AB is equal to AD, and angle BAD is equal to angle EAC. If you mention, I have written it as angle 1 and angle 2. Show that BC is equal to DE. Now first of all, we have written the given part, what all is given to us in the triangle, and if you see, angle BAD is equal to angle EAC, I have mentioned is as equation number 1. Now first we need to think over which triangles we have to take. Now with the help of what we have to prove, we need to prove BC is equal to DE. Now BC is the form of triangle ABC, and if I say DE, DE includes in triangle ADE. That means we need to focus on these 2 triangles, and in these 2 triangles we notice that 2 sides are equal, we are given. And in the third, the angle which is given to us equal, that is partial. In between, if you say there is a part, say you can say angle DAC is there, which is common in both the triangles. So what we will do is, in order to get a proper angle, we will add angle DAC in both angle 1 and angle 2. When we add that, we will get the whole angle BAC and BAE. That is the full angle of that triangle. Now let us take these two triangles and try to make it congruent. Now we have already proved angle BAC is equal to angle DAE. AB is equal to AD. It is already given in the question. And AC is equal to AE. That is also given in the question. So by SAS property, our triangles are congruent, and with the help of CPCT we can say that BC is equal to DE, as they are the parts of the triangle. Question number 7. AS is a line segment and P is the midpoint. D and E are the points on the same side of AB such that angle BAD is equal to angle ABE and angle EPA is equal to angle DPB. Show that the triangles DAP is congruent to triangle EBP. That means they are again talking about the full triangles. If you see the angles which they are given, okay, that is marked by the curved ones, that they both are equal. But the triangle over here, suppose you notice ADP. ADP angle includes EPD. Same way, if I look at the triangle EPB, again EPD, the center angle which is not marked, is common in both the triangles. So what will I do? I need the bigger triangles DAP and EBP. So for getting that and making the angles equal, as it is a common part, I will add EPD on both the sides, and because of which I can easily get angle APD is equal to angle BPE. Now let us take both the triangles and make them congruent. Now in the triangle DAP and triangle EBP, if you look at the triangles, we have two things with us. That means we have just proved that angle APD is equal to angle BPE, which is the part of the triangle, and we also know that AP is equal to BP because MP is the midpoint of the two things we know. What about the third thing? We don't know about the third thing. Third thing will be angle PAD will be equal to angle PBE. Why? Because we are already given that BAD is equal to angle ABE. So we can extend this and we can give the reason of this. With the help of ASA criteria, we have proved that triangles are congruent, and when the triangles are congruent, we know that AD and BE, they both are the parts of the congruent triangle. So we can write down that AD is equal to BE by CPCT. Question number 8. In a right triangle ABC, right angle at C, M is the midpoint of hypotenuse AB. So if you see AM and MB, they will be equal, and C is joined to M in such a manner it's produced to D, DM is equal to CM. So it is already given to us. Now we need to prove that triangle AMC and triangle BMD are congruent. That means opposite triangles. So let us see in triangle AMC and triangle BMD what all we have with us. We have equal sides. CM is equal to DM. It is given to us. And angle AMC will be equal to angle BMD because of vertically opposite angles. And we also have AM is equal to BM, which is proved above, or which is also given to us, that they are equal because M is the midpoint. So triangles are congruent by SAS. Second, they are saying that angle DBC is a right angle. Now we are already told that angle ACB is at right angle, C is at right angle. We need to prove that angle B is also a right angle. So let us see. Now when the triangles are congruent, both the triangles, we can say that angle MAC is equal to angle MBT. Okay, what is this? They are forming the alternate interior angles, and we can say that AC is parallel to DB. When lines are parallel and we can take BC as a transversal, we know that angles formed on the same side of the transversal, they form co-interior angles, which means their sum will be equal to 180 degrees. So we can write it as angle DBC plus angle ACB is equal to 180 degrees. One angle is already 90 degrees, that is angle C. Therefore, angle B or angle DBC will also be equal to 90 degrees. Third part, let us see what we have to prove. In the third part, we have to prove angle DBC is congruent to triangle ACB. So let us prove it. I have the figure here also. Now because we have proved triangle AMC is congruent to triangle BMD, we can say that AC is equal to BD. By CPCT, we need to have something common or equal there. Now when are we taking bigger triangles? Now DBC and triangle ACB. Now DB is equal to AC, we have proved above. Both the angles are 90 degree. This is also proved above. And CB is equal to CB, which is common. By this we can say that both the triangles are congruent by SAS. Let us see the fourth part. Fourth, they are saying that CM is equal to half of AB. Let us see. What is CM? When the triangles are congruent, we can say that DC is equal to AB by CPCT, because we have just proved the triangle, full triangle DBC congruent to triangle ACB, and DC and AB are the parts of the same triangle, congruent triangle. So we can say that by CPCT DC is equal to AB. But we know that DM is equal to CM because M is the midpoint. It is given in the question that CM is reduced to D such that CM is equal to DM. It is given. So we can simply write down that CM will be half of AB. Why half of AB? CM will be half of DC. Now what is DC? DC is equal to AB. We have proved above. So we can replace it by writing it as CM is equal to half of AB. So children, with this we finish exercise 7.1, and in the next video I am going to teach you 7.2 exercise. And before that, I would like you should watch the concepts videos which are already there on the YouTube channel. Please go through that and understand what all properties are there which we are going to focus upon and how we are going to proceed further. I hope you have understood all the questions clearly and carefully. If you have any doubt anywhere, either you can comment section or you can send me the mail. Thank you so much. Take care, children.